Today we will see about histogram equalization. Histogram equalization is a method used to automatically enhance the contrast of an image by redistributing the intensity values which are gray levels. It is a method of image enhancement only. Basically what it will do is it will redistribute the intensity values in the image itself. If you see the second point, you will understand clearly. It spreads out the most frequent intensity values in an image, making low contrast areas more visible. Like in an image, if you see in an image, there are some points are very high, some points have more intensity value, some points are low intensity values. So the which have more intensity values, right, they will distribute the intensity value to low contrast areas. So these low contrast areas also can be seen clearly. Basically high intensity values give their high intensity values to low intensity values, so we can see clearly. If you want to know where it is used, not where, why it is used, some images may be too dark. If you want to know why it is used, some images may be too dark, too bright, or have a poor contrast, making it too difficult to see the details. Histogram equalization improves such images by flattening and stretching the dynamic range of the histogram. Or some areas as too dark in an image. If you see, some places are too dark, some places are too bright, and some places some poor contrast. So which are too dark, right, the intensity values are shared between themselves. So to make the image look clearly, it will distribute their intensity values in image itself, so the image can be seen clearly. And where it is used is, it is used in medical imaging like X-rays, satellites, and remote sensing, photography and forensics, industrial vision systems, etc. If you want to see the numerical, here they have given the histogram equalization for an image. In an 8x8 image, they have given this question. These are the gray levels 0, 1, 2, 3, 4, 5, 6. These are the number of pixels, like how many zeros are there in an image, how many ones are there, how many twos are there, how many threes are there. Like there is a matrix, right? In those matrix, how many zeros are there, we will calculate this. How many ones are there, like this. So this is the question. First we will draw the graph, histogram graph for the given question. For 0, it is, for how many zeros we have, 9. How many ones we have, 8. How many twos we have, 12 or 11. How many threes we have, 4. How many fours we have, 10. How many fives we have, 15. How many 6 we have, 4. How many 7 we have, 3. So we need to distribute these pixels within itself, so it will make image seen clearly. So first we need to calculate PDF and CDF. These are the gray levels, input images only, 0 to 7. We will represent it as RK, and these are the number of pixels, like how many 0 pixels are there, how many 1 pixels are there, like that. We will represent it by NK. This is N. I didn't write this N. This is N. This is the total number of pixels are there. This is 8x8 image, right? So there are total 64 images are there. PDF formula is this NK by this N, like 9 by 64, 0.141, like that. And CDF formula is by adding the PDF values, 0.141, like that. We will see it later. And this one is SK into 7. CDF will be represented as SK. So this column is SK into 7, this into 7. And histogram equalization level is, we will round off this to nearest integer value. So it is the new histogram equalization level. So first one is gray level for input 0. We will see this one. Number of pixels we have is 9. This will be given in the question only. And PDF is 9 by 64. So this is 0.141. CDF is 0.141, same only for first row. And this is SK into 7, 0.141 into 7, that is 0.987. We will round off this to 1, nearest integer is 1. And for 1 input image, number of pixels we have is 8. And PDF is 8 by 64, so 0.125. And CDF is whatever value is there, 0.141 plus 0.125, that equal to 0.266. And SK into 7 is 0.266 into 7, 1.862. And the nearest integer value is 2. And for input 2, number of pixels we have is 11. And PDF is 11 by 64, 0.172. And CDF is 0.266 plus 0.172, that equal to 0.438. And SK into 7 is 0.438 into 7, 3.066. And histogram equalization level is 3. And for input 3, number of pixels we have is 4, and PDF is 4 by 64, 0.0625, and CDF is 0.438 plus 0.0625, 0.5005, and SK into 7 is 0.5005 into 7, 3.5035, and nearest integer value is 4. And for 4, the number of pixels we have is 10, and PDF is 10 by 64, 0.156, and CDF is 0.5005 plus 0.156, 0.6565, and SK into 7 is 0.6565 into 7, 4.5955, and histogram equalization nearest value is 5. And for input 5, number of pixels we have is 15, and nk by n is 15 by 64, that equal to 0.234. CDF is 0.6565, 0.5005 plus 0.156, 0.6565 plus 0.234, 0.8905, and SK into 7 is 0.8905 plus 0.8905 into 7, that equals 6.2335, and nearest histogram equalization level is 6, nearest integer is 6. And for input 6, number of pixels we have is 4, PDF equal to 4 by 64, that equal to 0.0625, and CDF equal to 0.8905 plus 0.0625, that equal to 0.953, and SK into 7 is 0.953 into 7, 6.671, and nearest integer value is 7. And for 7, input 7, number of pixels we have is 3, and PDF is 0.047, 3 by 64, that equal to 0.047. CDF is 0.953 plus 0.0447, that equal to 1, and SK into 7 is 1 into 7, that equal to 7. Histogram equalization level is 7, is same as integer only, so we will represent 7 only. So these are the input values, these are the new histogram level values. So if you see output, what it is, gray levels, new gray levels are 1, 2, 3, 4, 5, 6, 7 only, there is no 0, so 1, 2, 3, 4, 5, 6, 7, and number of pixels we have is, for 1 it is 9, for 2 it is 8, for 3 it is 11, so we will make for 3 it is 11, for 4 it is 4, so we make 4 it is 4, for 5 it is 10, so we will mark it as 10 here, for 6 it is 15, so we will mark it as 15, for 7, look it carefully, for 7 there are two values, so we will sum those two values, 4 plus 3, we have 7 pixels here, number of pixels, so for 7 there are total of 7 pixels are there. So these are the new pixel values, number of pixel values to the corresponding gray levels. So based on that new corresponding pixel values, for there is no 0, for 1 it is 9, for 2 similarly we will mark it as histogram for new values. If you want to convert, how, if they given the input value is this one, right, how to convert to this one means we will see here. First we will see this image, highest value is 7 in this pixel image, so 2 cube equal to 8, it is between 0 to 2 cube, so L equal to 8, L minus 1 equal to 7, so basically there are 0 to 7 values are there. Gray levels are 0 to 7, we will mark it as 0 to 7. Number of pixels we have, we will count number of zeros in there, 0, we will count number of ones are there, 1, 2, 3, there are 3 ones here, and there are a number of twos are there, means here it is 1, here it is 1, 2, there are two twos. Number of threes in the given pixel is 1, 2, 3, 3 pixels. Number of fours in the given pixel is, given image is 1, 2, 3, 3 fours are there. Number of fives in the given image is 1, 2, 2 pixels are there. Number of sixes are means only 1. Number of sevens is 2. So this is how we will represent this one. This is how we will convert the given image to this format, what we will need here. So this is the histogram equalization. We will see about histogram matching in the next chapter, next video. Bye bye.